Here we go with the graph of the cosecant function. We define the cosecant as the reciprocal of the sine. So what that means, my cosecant is going to be undefined everywhere that the sine is 0. I'm going to, in fact, have a vertical asymptote. The cosecant function will have a vertical asymptote everywhere that the value of sine x is 0. And that happens, let's see, sine of 0 is 0, sine of pi is 0, sine of 2 pi is 0, sine of negative pi is 0. Any whole number multiple of pi will make the denominator 0, which gives us a vertical asymptote on the graph. Okay, so I got some asymptotes coming. Let's set up the graph here. X equals 0 is an asymptote. It's also an axis, so it's hard to make it be an asymptote too. There's pi. Here's 2 pi. Try and get those evenly spaced there. There's another one back here at negative pi, and so on forever in both directions. Every whole number multiple of pi, there's an asymptote. Since the cosecant is the reciprocal of the sine, it can be useful to kind of sketch in the sine graph, just to kind of use that as a guide. We can come back this way if we feel like it. The top's at 1, the bottom's at negative 1. Well, let's see. We need some more points, or we need some points. We don't have any. All we have is asymptotes so far. At x equals pi over 2, sine of pi over 2 is 1. 1 over the sine of pi over 2, 1 over 1, also 1. So I'm going to have a point on the graph right there at 1. At 3 pi over 2, sine of 3 pi over 2 is negative 1. The reciprocal of negative 1 is negative 1, so I'm going to have a point there. Same thing over here at negative pi over 2. And then we're going to think what happens next. As I go towards pi, as x goes towards pi, sine of x is getting smaller and smaller and smaller, going towards 0. 1 over something very small is something very large. 1 over 1/1,000,000th is a billion. 1 over something very small is something very large. So as I get closer and closer to 0 and my sine x values get smaller and smaller, my 1 over sine x values, my cosecant values, are getting bigger and bigger. And that fits in with what we know about how vertical asymptotes work. Over here at between pi and 2 pi, the same thing is happening, except for in quadrants 3 and 4, sine x has negative values. So we're going down along the asymptotes instead of up along the asymptotes. If we take a look here, this is one complete period of the cosecant function. We need both of those to get one complete period. We don't start over until we get past the next asymptote. So the period of the cosecant function is 2 pi. It takes 2 pi before it starts over and starts repeating itself. The domain, I can find the cosecant of anything except where the asymptotes are. So all real numbers except where the asymptotes are, x equals any integer multiple of pi. For the range, we have this no-fly zone here in between -1 and 1. The sine function is in there, but that's not part of the cosecant function graph. We just put that in there for some guidance. So range, I can go down as low as I want. I'm going to go down along this asymptote forever, so I can any y value I want in the negative direction, but only up until -1. And then we stop and we have this desert here, and we start up on the other side of the desert at 1, and then my y values I can get as big as I want from there. So domain and range. And let's look at what we have, the hand-drawn picture, and that's okay, but let's take a look at the lovely Desmos version. There it is. So that's 3 periods of the cosecant function.